Okay, so I'm going to be going over the lab that we're going to be working on tomorrow. And this lab is a little special because we're going to be dealing with more chemistry type labs, so there's safety is a big issue. It's called a calorimetry lab, and a calorimetry lab is just a lab that uses the concept of calorimetry, which is your MCAT. So what we're going to be doing is we're going to be identifying unknown materials by their specific heat capacities and comparing them to accepted values of specific heat capacity. So really what's going to happen is I'm going to give you an unknown sample and you're going to do some tests on that sample to find out what it is. So it can be zinc, it could be aluminum, it could be copper. You're going to figure out what that sample is by doing calorimetry tests on it. Okay, so the big thing here is safety is going to be a big issue for this lab. Unlike a lot of our physics labs, the biggest thing that could happen, maybe you could drop a mass on your toe, and the mass is normally, 0.5 kilograms, so it's not going to be a big danger. But in this one, we do have some issues of safety, so it's really important. So make sure the first one is always wear your goggles. We're going to be boiling water, and so the beakers can explode. The hot beaker can crack, causing hot water. We're going to be using thermometers in the water. We're going to be lifting and moving hot samples. So having goggles on is very important. And unlike the other lab, it is very important, even if you do wear glasses, regular glasses, make sure that you have your goggles on as well. Okay, the other one is you have to be wearing long pants and closed-toed shoes. An apron is not going to be acceptable this time because the hot water can, the wax that we were doing in the other lab was so small. This time we're going to be dealing with larger amounts of water, and we're going to be moving that water from one area to another, and so the chances of spilling are greater than the other lab. And then the last one, make sure that if you have long hair, that you pull it back into a holder. And that's not really a big issue because I do have some, stationary type rubber bands for your hair. They don't feel good, but they can at least do the purpose of holding your hair back. Those are more office supply rubber bands. But the big thing is make sure that tomorrow that you have long pants on and closed-toed shoes. The goggles I'll supply, and make sure you have something to hold your hair back in. Okay, so let's look at pre-lab. This is what you're going to have to come ready to do tomorrow. So the first thing is I'm going to have a lab that you're going to print off the procedure from Chapter 12 folder on Edline. And that's the procedure. This is not a procedure that you're going to copy. You just have to print it out to make sure that you have a hard copy that you can use tomorrow while you're doing the lab. The other thing is you're going to make sure that you create a table on your computer. So this table is going to have 3 columns here, trial 1, trial 2, and trial 3, and then a 4th column that's going to have the information. And then we're going to have 1, 2, 3, 4, 5, 6 rows. The first row is going to be the mass of the sample. So I'm going to be giving you a sample. You're going to have the mass of the sample, mass of the calorimeter and the stirrer, the mass of the water, the initial temperature of the water and the calorimeter, the initial temperature of the metal, or the metal sample, and the final temperature of the metal, the water, the calorimeter, and the stirrer. So this is what your table is going to look like. And make sure you have enough room that you can put your information in the chart when you do the lab. So this is what you're going to be doing for your pre-lab. Okay, so now, although you are going to copy off the procedure, a hard copy of it, I'm going to go over it today in this video that's going to kind of help you understand what we're going to be doing. So all I did was draw some pictures rather than me write out these whole paragraphs. But our first step is you're going to take an empty beaker and you're going to fill it with about 200 milliliters of water. Now the amount of water is not important because we're going to be taking the mass of the water, and so if you have more than 200 milliliters or less than 200, the key thing is that you have to have enough water that once it's in full boil it covers the sample, because you don't want that metal sample kind of outside of the water and anything like that, like an iceberg or something like that. So you're going to get 200 milliliters of water, and you're just going to get this from the tap in the back of the lab, and you're going to put it on a hot plate and you're going to watch it boil. And this part is going to take the longest amount of time, so you're really just watching water boil. Okay, so you have to make sure that You have the hot plate has to be turned on. While the water is boiling, use this time that you have some partners in your lab and your lab group, and make sure that you already know what each person's going to be doing. One person needs to keep an eye on this, while another person's going to take your unknown sample and take the mass of that. So you're going to put the mass of the metal on a scale and get the weight of that. At the same time, you're going to be able to take the mass of the calorimeter and the stirrer and the thermometer if it comes with it, and you're going to have to get the mass of the empty calorimeter and all the supplies that go with the calorimeter. And that all is going to be happening while you're boiling this water. Once the water comes to a boil, you're going to stick the specimen inside the water. And the reason we haven't done the lab yet, this part is not the lab, this part is the prep for the lab. We're going to be heating up this metal sample to a higher temperature. So what we're going to be doing is looking for this to go to a full temperature, a full boil, and no longer have a rise of temperature. So your thermometer's in here and it's going to be rising, the temperature's going to be rising and rising, and once it stops rising for 2 minutes, then you know that you've gotten an equilibrium temperature. Then we can say that the temperature of the sample equals the temperature of the water. Okay, one of the key things here is make sure that thermometer is not touching the bottom of the beaker, because then you're going to be getting the temperature of the beaker and the hot plate and not the temperature of the water and the sample. Okay, so once you've gotten that full thing here, then what you're going to be doing, once it's come to a full boil, you're going to send another lab partner and you're going to fill your calorimeter cup with cold water. And this is going to be special water. You don't want to take this from the tap. This is going to be water that I've had in the refrigerator for all day. Make sure that it's colder than room temperature. Then you're going to get a mass of this. And once again, the amount of water isn't important, just that you have enough water that's going to cover the sample. So if your sample is this big, you need to have water that big. If your sample is this big, you only need this much water. It has to fully cover the sample. Here you're going to take a mass of the whole thing together, and then what's going to happen, you're going to take a temperature of the cold water and the calorimeter. And this is going to be your initial temperature of the calorimeter and the water. Then what's going to happen is you're going to take, and this part over here is where it gets a little bit confusing, you're going to take tongs and get that hot metal sample out of the hot boiling water, and you're going to put it inside the calorimeter cup. Okay, so right over here, you're going to make sure that you cover that calorimeter cup so that none of the heat leaves into the environment and it just stays in this system right here, and you're going to watch the time. Okay, so here you're going to be watching the time and you're going to be recording the temperature every 5 seconds. Okay, so it's really important at this time that you're recording the temperature every 5 seconds. What you're looking for is that the change in temperature, there becomes no change in temperature for 5 consecutive readings. So if you're watching it rise and it's rising and every 5 seconds it's rising and then it stops rising, and then you take another 5 seconds and it hasn't moved, and another 5 seconds and it hasn't moved, and another one, and then another one, and the temperature hasn't moved, then we can assume that that's now at equilibrium temperature. And at that time, you're going to record that temperature, and that is your final temperature of the calorimeter and the metal sample. And that's our key value right there. And the final step is that I have this blob right here. That just means there's nothing there. You've completely cleaned up your lab area. Make sure that your hot plate has been turned off. Make sure all the water in the beaker up here, as well as the calorimeter, has been dumped down the drain. You're not going to keep everything. Make sure you've put all the supplies away. And lastly, make sure that your metal sample goes back to me, because I know what your sample is and I'm going to be needing to know if you received or calculated the correct value. Okay, so that's really what our lab entails. If you go onto chapter 12 and you download the lab, you'll go through the analysis and also the conclusion. We're also going to have an article that I'm going to have you read pertaining to this, and we're going to be doing that tomorrow today or tomorrow in class, and you're going to be answering some questions pertaining to the article as well. So the key thing tomorrow, don't forget the safety issues. Make sure, once again, that you have your long pants on and your closed-toed shoes tomorrow, or you will not be able to do the lab and you're going to have to come in on your own time. and also that you pull your hair back. Okay, so that's all we have. Make sure you have the safety requirements and your table, and we'll see you tomorrow and ready to do some heat transfer. We'll see you tomorrow.